Hi, in this video I will demonstrate how you can solve a dep-3 challenge by calling three functions to read out the flag. And let's check the readme file first. And what it says, can you run the following functions by exploiting a buffer overflow vulnerability? So by exploiting one buffer overflow vulnerability, the task is that we need to call three functions. Then what it does is it's just uh, opening the flag file and then read the data from the buffer, and then write the data that we read from the flag file to the standard out. Yeah. Then we can see the flag on the console. So instead of running the shell and the run cat flag, we can read out the flag by running these following three functions. And in dep-2, we practice that how we can call a single function, and then right now it asks us to call multiple functions, open, read, and write in chain with the 2 to 3 arguments supplied in exploiting the buffer overflow vulnerability. And let's just try the first one first. So try to call the open function first, and then can take a look at the source code of the dep-3. And then one of the trick that we can chain three functions, open, read, write, is that there is a sum function in the dep-3, and then we can call this function, then it will try to open a.txt. And one of the tricks that we can use is that we can create a symbolic link of the flag file to a.txt, then opening a.txt will open the flag file. So we will use that. So the first thing is that we can just call sum function as we did in like a dep-1 challenge. And to do that, we need to locate the buffer overflow vulnerability here, which fills twice the size of the buffer. And then we need to locate that in the binary format. So run gdb, disassemble the input function. Then we can know that buffer is at ebx, and that's ebp minus 888. So after knowing that, we can write the exploit script. dep-3, and then our buffer is at ebp minus 0x88, and then we can fill here as if filling the ebp, and then we need to put the address of the sum function here. So to do that, we can convert to the symbols dictionary sum function to get the address of sum function. Then maybe we can do this. Then how we fill the stack is something like then return address as like this. And then we will fill AAA here for example, and then it's just EBP plus 8, and then we wrote the AAA here. And then let's check how it is being executed, and to do that we will use GDB. So set up the context, and then attach that, and then we can copy dep-3 to depx to enable debugging, and like this. Then change it to depx. And then another thing is, for our convenience, we can set a breakpoint at the end of the input function at the return to follow how it is being executed. So we can copy this address and set the breakpoint right after we attach to GDB. Then the current buffer is something like this, and then we can send buffer and then run it. And let's run the script, and then we can continue to the end of the input function because we set the breakpoint, and then right now it returns to some function. And let's check how it is being executed. So we get into some function, then it will move and then call open with the file name a.txt, and the flag is 0, and then there's a variable argument that's AAAA because we put that as a return address +4, so yeah, I regard that as an argument. And then let's call it, and its return value is -1 because right now we do not have a.txt. Yeah, so then it will leave and return to which address? 41414141, and then that will be an invalid address. So what has been done is, so after returning from some function, it will return to the next address that we put on the stack, but because we fill AAAA here, so it hashes that there. And then what we want to do is we want to read some data and then write out some data. Yeah. So to do that, we need to chain these three functions and then just putting the function address right next to the another function address, the previous return address. This will consecutively run the sum function first, and then read the next, and then printf at the last. And then we will construct our stack like this. Then it will run all three functions sequentially. And then if we successfully open the a.txt, then we will see the file descriptor number, and then that will be 3 because we have a 3 file descriptor that has been already opened. So 0 for standard in, 1 for standard out, 2 for standard error. So the first file that we will open will be always get file descriptor 3 unless we specify something. Yeah, so that's why. And then we will call read file descriptor 3 from the a.txt, which is a flag file that we run the symlink on it. Then put any kind of the writable address, and then read some amount of data. Then we will print out that value. So we just verify that it will run this AAAA as next, and then what we will do is we will put AAA as a read function, and then EBP plus C will be, so another function that we would like to run could be printf, and then this one will be the first argument of the read, so we will put 3 as a file descriptor, and then for this one is a second argument. Second argument of the read. Then this will be third argument of read. So maybe we can put 255, so sum of the length longer than the flag size, and then you can see the flag length is 21 bytes. Yeah. So any number larger than 21 will be fine. And then another thing is like we need to figure out some of the address that we can write, and you can do that with the VM map. So if you run the GDB with dep-3 break and main and run it, and then run VM map, then we can see that there is an area that we can read and write. And at here, maybe we can put some number as 80E9800. Yeah, then we can see that these values are empty and not being used, so that we will use this address. So the address was picked as like the writable area of the binary program, and then I picked just added like the 8 here to skip some of the part that the program actually uses. So we will use this address as a buffer. And then that's the second argument, and then third argument. So we are basically call some function. This opens a.txt, the read, then read 3, something like this. And to call that, we can chain the address as address of read function, blah here again, maybe bb, and then file descriptor 3, and then the buffer address that we will use, and then size of the read. So basically we can craft this as, this will call some function, then this will call read 3, this function, and then finally we want to print the buffer. Then we can read out the data that we read from the flag to the console output. And to do that, what we will do is we will just put address of the printf here. So what we need is address of read function, address of printf. Maybe we can do something like this. Yes, like this. Then you can see this diagram. So read, its first argument is 3, second argument is this one, and then third argument is this one. Then what about the printf? Fortunately, the first argument of the printf is the buffer. So that's why just having the printf here, it will use the first argument as a buffer. So what it will do is just calling the printf address of the buffer. So we finished to construct the exploit chain, but the remaining thing is like we need to figure out where the read and then printf function is, and then to do that we can run gdb print read print printf. There are all the functions in here because dep-3 is not a dynamic executable, so it has all the functions that we use in the program. For example, we have many functions from the libc here, but the problem is that we don't have system function, we don't have execv, execl, these kind of functions. So that you cannot execute the program, but you can run printf, read, this kind of function, and then that's why you need to construct a buffer like this. And to get the address of the read, we can do p.elf the symbol read, and then p.elf the symbol printf, and we can get the address of these two. Then we will send this buffer, and then we will see that this actually runs a sum function, read function, and printf using GDB. And before running that, we need to create a flag, and then that will be linked as a.txt. But right now we will examine that with debuggers, so we will create the a.txt with the fake flag here, like this. And then later we will change that to a symlink to the flag. So instead of the real flag, it will read this fake flag. Then let's run the script. And right now we are in the debugger. Oh, so I made a mistake. It does not have a attribute to symbol. It should be symbols. Yeah. Now it is done. Then run it. Then continue on the debugger. We'll stop at the return of the input function. And then the next instruction will be calling a sum function. So we return to sum function first, and then read, and then printf. So now it is in the sum function. We will go down. It will call open a.txt, and then check the return value, the EAX register. The value stored in the EAX is that the file descriptor number 3. So it means that the a.txt has been opened successfully because we created a file. Yeah, and then it will do leave and return, and now it returns to the read function. Yeah. And then we are in the read function, but what it does is like the first argument is a 3, second argument is this address, then third argument is the size. So it will call the read function and then return. And in this address, now it read the fake flag here, the content of the file, to the buffer, and then it returns to printf, and then its first argument is this address. Then if we just run continue, then it prints out the fake flag here. Yeah. And then finally, you can change the script by removing gdb.attach, and then dep-3, change the binary name to dep-3, and then removing the a.txt, and then create the a.txt as a symbolic link of the flag. Then you cannot get a.txt, but if you run the exploit.py, then you can see the flag at here.